Dear students, welcome to my 4th class on Module 2 Fourier series. In this lecture video, we're going to discuss about Fourier series of periodic functions of arbitrary period. So the formula to calculate the Fourier series of arbitrary period in the interval minus L comma plus L. The formula is f of x is equal to a naught by 2 plus summation n from 1 to infinity a n cos n pi by L into x plus summation n from 1 to infinity bn sin n pi by L into x. So where a naught is equal to 1 by L, summation minus L to plus L f of x dx, a n is given by 1 by L minus L to plus L f of x cos n pi by L into x dx, for n is equal to 1, 2, 3 and so on, and bn is equal to 1 by L, the integral minus L to plus L f of x sin n pi by L into x dx, for n is equal to 1, 2, 3 and so on. So here also we'll be following on to two cases. The first case is the function is an odd function in the interval minus L to plus L. The function is odd means the value of a naught will be equal to 0, a n will be equal to 0, only bn we have to calculate with this formula, that is 2 by L integral 0 to L f of x sin n pi by L x dx, for n is equal to 1, 2, 3 and so on. Similarly, the function is an even function in the interval minus L to plus L, only bn will be 0, we have to calculate a naught as well as an. The formula for a naught is 2 by L integral 0 to L f of x dx, and an is 2 by L integral 0 to L f of x cos n pi by Lx into dx, for n is equal to 1, 2, 3 and so on. The problems on arbitrary interval. Obtain the Fourier series expansion of f of x is equal to x cube in the interval minus 2 comma plus 2. So we can find the value of L from this interval only. So the value of L will be equal to 2 here. So the given function is f of x is equal to x cube in the interval minus 2 comma plus 2. It implies that the value of L will be equal to 2. So now we have to verify the function is odd function or even function. So clearly x cube is always an odd function. Therefore the function f of x is an odd function. So since the function is odd function, the coefficients a naught and an will be 0. So now our job is to find the value of bn only. So before that, take the formula f of x. So f of x is equal to, we have a naught by 2 plus summation n from 1 to infinity an cos n pi by lx plus summation n from 1 to infinity bn sin n pi by lx. Call this one as equation number 1. So now I am going to find the value of bn. So bn is equal to, we have 2 by L integral 0 to L f of x sin n pi by Lx dx. So now here I am going to replace the value of L is equal to 2 and the function f of x is equal to x cube. So we got bn is equal to 2 by 2 integral 0 to 2 x cube sin n pi by 2 x dx. So now I am going to apply the Bernoulli's condition, taking x cube as u and sin as v, applying the Bernoulli's condition. So we got, after applying the Bernoulli's condition, the equation is bn is equal to x cube into minus cos n pi by 2x by n pi by 2 minus 3x square into minus sin n pi by 2x by n pi by 2 whole square plus 6x into cos n pi by 2x by n pi by 2 whole cube minus 6 into sin n pi by 2x by n pi by 2 whole power 4 with the limit 0 to 2. So now applying the upper limit, replacing all x terms by 2. So we got 2 cube minus cos n pi by 2 into 2 by n pi by 2 plus 3 into 2 square sin n pi by 2 into 2 by n pi by 2 whole square plus 6 into 2 into cos n pi by 2 into 2 by n pi by 2 whole cube minus 6 into sin n pi by 2 into n pi by 2 whole cube whole power 4. After simplifying this, we got the equation like 0 into cos 0 by n pi by 2 plus 0 into sin 0 by n pi by 2 whole square. This is for lower limit, minus 0 into cos 0 by n pi by 2 whole cube plus 6 into sin 0 by n pi by 2 whole power 4. So we can note that the complete lower term will become 0 here. And so like after simplification of upper limit equation, so we got minus 8 into minus 1 power n by n pi by 2 plus 12 into 0 because sin 2n pi is 0 plus 12 into minus 1 power n divided by n pi by 2 whole cube minus 6 into 0 because sin n pi is 0 here also. So after simplifying this, we got minus 16 by n pi into minus 1 power n plus 96 by n cube pi cube into minus 1 power n. So by taking 16 by n cube pi cube common factor, we got bn is equal to 16 by n cube pi cube into minus 1 power n. 6 minus n square pi square is the required value of bn. So now this a naught, an, bn, so take in the equation number 1. So therefore 1 implies that f of x is equal to 1 by 2 into 0 plus 0 plus summation n from 1 to infinity 16 minus 1 power n by n cube pi cube into 6 minus n square pi square into sine n pi by 2. So after simplifying this, we got x cube is equal to 16 by pi cube summation n from 1 to infinity minus 1 power n by n cube 6 minus n square pi square into sine n pi by 2 into x is the required solution. Example number 2. Expand the function f of x is equal to 1 plus 2x for minus 3 less than x less than 0 and 1 minus 2x for 0 less than x less than 3. It's a discontinuous function here. So now for this function we have to find the Fourier series. Also we have to find that pi square by 8 is equal to summation n from 1 to infinity 1 by 2n minus 1 whole square. So first thing is check the given function is order even. So take the given equation first. F of x is equal to 1 plus 2x for minus 3 less than x less than or equal to 0 and 1 minus 2x for 0 less than x less than 3 in the interval minus 3 comma plus 6. So it implies that the value of L will be equal to 3 here. So now to check the function is order even, I'm going to replace x is equal to minus x. We got this equation. After simplifying, we got f of minus x is equal to plus f of x. So hence the function is an even function. So since the function is even, only bn will be 0. We have to find the coefficients a0 as well as an. So we'll find a0 first. So first take the main formula. So we have f of x is equal to a0 by 2 plus summation n from 1 to infinity an cos n pi by lx plus summation n from 1 to infinity bn sin n pi by lx, and it is equation number 1. So finding a0, so replacing L is equal to 3 here. So 2 by L integral 0 to L f of x dx. So 2 by 3 integral 0 to 3 1 minus 2x dx. So after integration we got 2 by 3 x minus 2x square by 2 with the limit 0 to 3, and simplifying this we got a0 is equal to minus 4. So in the same way finding an, the formula for an is 2 by L summation integral 0 to L an cos n pi by lx dx. So now replacing L is equal to 3 and the function 1 minus 2x here for the given limit. So we got an is equal to 2 by 3 integral 0 to 3 1 minus 2x cos n pi by 3 x dx. So applying the Bernoulli's condition, taking this one as u and this one as v. So we got 2 by 3 1 minus 2x sin n pi by 3x by n pi by 3 minus 2 into minus of cos n pi by 3x by n pi by 3 whole square with the limit 0 to 3. Applying the upper limit, this sine term will become 0. For lower limit also sine term will become 0. So we got 2 by 3 into 1 minus 6 into sine n pi by 3 into 3 by n pi by 3 minus 2 into cos of n pi by 3 into 3 by n pi by 3 whole square. For lower limit 1 minus 0 into sine 0 by n pi by 3 minus 2 into cos 0 by n pi by 3. So these two terms will become 0. Cos 0 is 1 and cos n pi will become minus 1 power n. So we got 2 by 3 into minus 2 minus 1 power n pi by 3 whole square minus 2 by n pi by 3 whole square. So take a common factor of 2 by n pi by 3 whole square. So we got the equation like 2 by 3 into minus 2 by n pi by 3 whole square into minus 1 power n into minus 1. So we got the equation like minus 12 by n square pi square into minus 1 power n minus 1. So therefore the value of an will be equal to 12 by n square pi square into 1 minus minus 1 power n. So now replacing all this a0, an, bn in the equation number 1. So we got f of x is equal to minus 4 by 2 plus summation n from 1 to infinity 12 by n square pi square 1 minus minus power n cos n pi by 3x plus 0, and after simplifying this we got f of x is equal to minus 2 plus 12 by pi square summation n from 1 to infinity 1 minus minus power n by n square into cos n pi by 3 into x. So now to find the next step, I am going to replace x is equal to 0 in the previous equation. So we'll be getting 1 is equal to minus 2 plus 12 by pi square summation n from 1 to infinity 1 minus minus power n by n square into cos 0. So this value we got from this equation. So by taking x is equal to 0 here also. So we got 1 plus 2, 12 by pi square, 2 by 1 square plus 0 by 2 square plus 2 by 3 square and so on. It will be equal to 3 pi square by 12 is equal to 2 into 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on. So taking 2 here, so we'll be getting pi square by 8 is equal to summation n from 1 to infinity 1 by 2n minus 1 whole square is the required solution. Thank you.